Hi and welcome everyone. In this lesson, we will talk about a very important topic inside the solar energy, or to be more specific, inside the solar batteries, which is called the data sheet of the solar batteries. This will help you understand well about solar batteries. Now, before we start this lesson, if you haven't subscribed to our channel, make sure to subscribe to the channel and hit the like button for the YouTube algorithm. Now, let's start. If we open a datasheet, for example, for a solar battery, an AGM battery with 12205, what does this mean? We will understand right now. So this is the name of the battery that I'm using from Trojan company. This battery, which is an AGM battery, its type is an AGM, as we will see right now. We are going to discuss it in this lesson. So as you can see, we started with, if you look at the specs, you will find the first part, which is the voltage. You can see this is the battery voltage of the battery, 12 volt. So the voltage taken here is 12 volt. Now the second part is the ampere hour rating, or the capacity of the battery itself, and the C rate of the battery. You can see this battery is a 205 ampere hour. This is the capacity of the battery itself. You can see it's also inside the model name 205, and the 12 volt is also in the model name itself. Now, what is really important is that you will find 205 ampere hour, which is the ampere hour rating, at 20 hours. What does that 20 hour mean? It is representing the C rate, or the discharge rate. So the 20 hours here representing C20. And we talked in our course for solar energy about C10, C20, and we said that C20, it means it discharges in 20 hours. Okay, now this capacity will change if the discharge rate will change, as we will see in this video. The third part, which is the type of the battery, you can see a valve regulated lead acid battery, or it's a type, this valve regulated or the sealed type battery is an AGM, or absorbed glass mate. Of course, we said before that sealed battery like AGM does not require any maintenance. Then the last one, which is important for us, is IEC 61427, 8 plus years life. So what does this represent? This is a standard developed by the International Electrotechnical Commission, or the IEC, for secondary cells and batteries for the PV systems. Now you have to understand that these batteries are subjected to tests under this standard, which involves the heavy discharging the batteries, which is a typical scenario in solar applications, in which we are talking about deep cycle batteries. In this test, they were stressed, and they were operating in abusive testing environment. Now, the years life mentioned in this data sheet beside this standard representing the expected lifespan of the battery when they are used in the PV system, and they are tested according to the standards that we talked about right now. So the lifetime of this battery can reach more than 8 years. Again, this lifetime depends on many factors, such as the depth of discharge. It depends also on the temperature, the storage temperature. It also depends on the operating temperature of the battery. All of these are factors that affect the life cycle, or the cycle life to be more specific. Another thing here you can find inside the datasheet is the physical specifications. You'll find here first the dimensions of the battery, which is the length of the battery, the width and height in millimeters, inches. This number is inches, and this one is in millimeter, as you can see here. Second one is the weight of the battery. how many pounds, 122 pounds or 55 kilogram. Then we have the electrical specifications, which are really important for us, is that you can see voltage and capacity and energy of the battery. So you can see the energy of the battery in kilowatt hour. So you can see here at 20-hour discharge rate. So when we are discharging our battery in 20 hours, we will get energy equal to 2.46 kilowatt hour. Now, where did we get this value? It is really easy. So we said before that the ampere hour of this battery at a 20-hour rating is 205. So if you take 205, which is the ampere hour, and multiply it by the voltage, you will get the energy. Ampere hour multiplied by voltage gives us the energy, which will give us 2.46 kilowatt hour. So this value obtained by multiplying the 20-hour capacity multiplied by the voltage of the battery itself. Now, very important part which we discussed before, we said that its charge rate or the C rating, C10, C20, C100, affects the capacity of the battery itself. So you can see this one is a 20-hour, a C20, 205 ampere hour. Now, as you can see that as the discharge time increase, as we talked before, as discharge time increase, you will find that the capacity of the battery starts increasing since we are discharging in a longer time. If you decide to discharge it in a shorter time, let's say 10 hours, then you will only get 174 ampere hours. So you will get lower amount of energy. Now this is really important because if you can discharge your battery in a longer time, it is acceptable. However, if you decide to discharge it in a lower time, it will affect its lifetime and you will get lower capacity than the rated value. Now the next one, which is the charging instructions. This is really important. Why? Because we talked about this before. We talked about the charging cycle of lead acid batteries and lithium ion batteries inside our course for solar energy. Now, when you these values, which you will find in the datasheet itself, is really important um, for the charge controller or the settings of the voltage settings of the charge controller. You can see here the charger voltage settings at the 25 Celsius degrees. Okay, at the 25 Celsius degrees. So these values will be used for the charge controller at the 25 Celsius degree. Now you can see that this battery can be 12 volt or can be connected to form 24 or 36 or 48 as you would like. Now the first important part, which is the maximum charge current. This is the maximum current that the charger can give to the battery without any damage. You can see here constant under or overcharging will damage the battery. So overcharging will damage the battery. So we cannot exceed the maximum charge current specified by the manufacturer itself. So the maximum charge current is 20% of C20. So what does this mean? Its value is 20% of the current at discharge rate of 20 hours. So the battery, if you remember, battery has a capacity of 250 ampere hour at C20. C20, which is the discharge rate, which is 20 hours. Now, I would like to find this equivalent current. So we have 205 ampere hour and we have 20 hours. So in order to get the current, we will take 205 ampere hour, divide it by 20 hours. So we will get 10.25 amperes. This is the current of the discharge current at rate of 20 hours. Now, the maximum charge current is 20% of this value. So we will say that 20% of C20, which is 20% of this value, will give us 2.05 ampere. So this is the maximum current that I can charge my own batteries with. Now the second part, which is the absorption voltage. Now if we are working at 12 volts, the absorption voltage will be 14.4 and the float voltage will be at 13.5. Now we talked before about the absorption voltage and float voltage inside the lesson of the lead acid and lithium ion charging cycle. And if you don't remember, the absorption voltage was the voltage after the bulk stage. So we said we have three stages of charging. The first one, which is the bulk charging phase, at which we will add which will supply the maximum charge current. Then we have, or after reaching 80 to 90% of the capacity of the battery, or its SOC, or the state of charge of 80 to 90%, then we will start using the absorption voltage to make the battery reach 100%. So if you remember, we said that the battery is charged at this constant voltage, which will lead to decrease of the charging current until it becomes very small and the battery will reach 100%. And we said that the float voltage is used to keep the battery at the state of a charge of 100% after a charging, or after the absorption stage. Now, and we said before that it is important because we have the self-discharge of the battery and we need to keep this capacity at 100%. So these values are really, really important. This one, this one, this one. And if you have a 24 volts, then you are going to use these values, 36, these values, 48, and so on. These values are really important to be added to the charge controller, the one which will help in charging our batteries. The next one, which is charging temperature compensation. Now, what does this even do? You can see that here, the charging temperature compensation, you can see 0.005 volt per cell for every 1 Celsius degree below 25 Celsius degree, and subtract 0.005 volt per cell for every 1 Celsius degree above 25 Celsius degree. So what does this mean? Now, if you remember that we said a 6 volt battery consisting of 3 cells, a 12 volt battery consisting of 6 cells. Here we are talking about the lead acid batteries, which is in this video. So the 3 cells, each one gives 2 volt, approximately 2 volt, giving us 6 volt. If we have 6 cells, then it will give us 12 volt, and so on. So in the 12 volt battery, let's say we have a decrease in temperature. So the previous values here, this value is at 25 Celsius degree. Okay. And let's say, for example, we are talking about the absorption voltage 14.4. Remember this, 14.4. So we have 14.4 volt. Okay. Now, for every 1 Celsius degree below 25 Celsius degree, add 0.005 volt per cell. So it will be plus, okay, plus 0.05 multiplied by number of cells. Since we are talking about a 12 volt, then we have 6 cells, so we will multiply by 6, and then we multiply by what? By the difference in temperature. So let's say we reach it at 10 Celsius degree, then it will be 25 minus 10 Celsius degree. Okay, and same for Fahrenheit, you will add this for the every 1 Fahrenheit. Okay, this will give you the new voltage. Now, if you are going to an increase in temperature, you will make this one a negative sign. Okay, this little compensation, this will help us in due to the change in temperature. Due as the change in temperature leads to change in the charging voltages, absorption, flood voltage, and so on. So you need to add this value, this small change, as a compensation for the charge controller itself. So the charging temperature compensation is used to adjust the charging voltage of the battery based on the operating temperature. This is important because the optimal charging voltage can vary depending on the temperature, as we have just said. For the lead acid batteries, we add a temperature compensation on the charger. To adjust for temperature variation is set to prolong the battery life by up to 15%. So why do we do this? Because it will help extend the lifetime of our battery. This will help also in preventing overcharging and undercharging of the battery to reduce its performance and lifespan. Now, before we go to the next slide, now you can see here we have also the self-discharge. You can see self-discharge. For the self-discharge here, you can see it is less than 3% per month depending on the storage temperature. So it means that less than 3%, so the battery will lose 3% of its capacity for each month, less than this value. But if you remember, we talked about the self-discharge before, and we said it will change depending on the temperature or the storage temperature. You will find in the datasheet also these curves that we will see right now in the next slides. Now, as you can see, another thing here, you can see operating temperature. So the operating temperature is between -4 Fahrenheit to 122 Fahrenheit, or between -20 Celsius degree and plus 50 Celsius degree. Now, one important thing is that you will find if the temperature is below 32 Fahrenheit or below 0 Celsius degree, you need to maintain a state of a charge greater than 60%. So state of charge greater than 60% means we are talking about a depth of discharge equal to 40%. So we said before that the lead acid battery recommended this depth of discharge is 50%. However, if the temperature became very low, this will affect the battery. So we cannot discharge more than 40%. Okay, so that temperature have a really high effect on the battery itself or the battery performance. Now remember the state of a charge. Here, this is another table that you will find in the data sheet. Percentage charge, cell, and voltage. You can see at 100%, the voltage will be 12.84. The open circuit voltage, when you get an avometer and measure the voltage across this battery, you will find it is 12.84 volt. Going down to 0, you will find it is 11.64. Now this value is pretty important to add to the inverter. If our battery reached this value, the battery should be disconnected from the inverter to prevent any further damage to the battery. So it is important to add this to inverter. This is the critical or the final value to prevent damage to the battery. If the battery reaches 0% and you start taking energy from it, it will start or it will be destroyed. You cannot take more than 0% of the battery. It still has some voltage, but if you take more than this, the battery will be damaged or be destroyed. So you have to make sure that you don't exceed 0%. And my own suggestion for you is that if you are using lead acid batteries, for example, we are using 50% depth of discharge. So if there is another source like the grid, for example, then you can assume 50% state of a charge inside the or depth of discharge, they will be the same inside the inverter itself. So for example, inside the inverter, I can say if the battery reaches a state of a charge of 50% and the grid is available, then in this case you can disconnect the battery. If the grid is not available and my own loads are critical and important than the battery, then you can discharge above 50%. Okay, this is found inside the settings of the inverter itself. Now another curve, this is what we talked about before, the depth of discharge or DOD, or how much I can take from the battery. So we said before that the depth of discharge affects the lead acid batteries, lithium ion, and any type of batteries. So we said that the depth of discharge for lead acid batteries, AGM is a lead acid battery, recommended one is 50%. So at a 50%, we can get approximately 1700, 1750, depends on the battery itself. This one is one curve for the batteries that we are discussing in this lesson. You can see that if you, for example, decided to use an 80% of the battery, 80% depth of discharge, you'll find that you will take only 1000 cycles instead of 1700. So as the depth of discharge increase, as we learned before, the amount of energy taken from the battery or the lifetime of the battery or number of cycles will start decaying. So the higher depth of discharge used, the lower number of cycles that can be taken out of the battery. So if you don't know about depth of discharge or you have forgotten about it, get back to our lessons. You will find the lesson for the cycle life and the depth of discharge. The next one is the percent capacity versus temperature. So you can see here the available capacity from the battery versus the temperature. You can see that here, for example, this is the temperature. So we are operating at what value? At 25 Celsius degree at this point here. Okay, so if you go like this, you will find it is approximately 100% of the battery is available for you. Now, if the temperature or the operating temperature starts to decay, if you are operating in a region less than 25 Celsius degree, then what I'm going to do is that I'm going to, let's say for example, I'm operating at 5 Celsius degrees. Okay, here is the equivalent temperature in Fahrenheit, as you can see here in Celsius degree. If I am operating at 15 Celsius degree, you will find that the available capacity will be about, let's say, 70%. Okay, 70%. So our battery now has two factors, depth of discharge, and we will have a temperature compensation if you are operating at a low temperature. So if you are operating at a temperature less than 25 Celsius degree and going down, you need to look at this curve, which you will find in the datasheet or the specs of the battery. It will help you select the correct one. This is one which is called the temperature compensation correction factor. So it is a correction factor. You need to make sure to add this in your own calculations if the temperature of the location decreased a lot beyond 25 Celsius degree. So you'll find that the lower temperature, the lower the ampere hours that can be taken from the battery. Then we have the self-discharge curve, which we talked about before. If we have a battery with 100% state of charge, completely charged or fully charged, then we start storing it for a couple of months. Now, you will find that the state of charge will start decaying with time. Decaying with time, as you can see here. Now, why is this? Because the battery inside it has its own internal chemical reactions, which will lead to self-discharge of this battery. Now, you will find that the self-discharge, it changes depending on the temperature, 10 Celsius, 25, 30, 40. So the lower the temperature, the lower the self-discharge happening to the battery. So as you can see here at the 10 Celsius degree, for example, for 14 months, look at the three curves here. At a 10 Celsius degree, we are beyond 75%. At a 25 Celsius degree, we are about 50%. For the 30 Celsius degree, about 30%. So you can see as the temperature increase, the self-discharge increase. That's why when we store our batteries, we store them in a cold location. This will help us to extend the lifetime of the battery or reduce the self-discharge inside the batteries itself. So you can see here the higher the storage temperature, as you can see 40 Celsius degree. So let's delete all of this. At 40 Celsius degree, you can see that self-discharge is very fast. So the higher the self-discharge rate of the batteries, higher temperature, higher self-discharge. Another thing which you can see is the performance curve. Here, this will give you the amount of amperes and the time. So it gives us the discharge current and the equivalent time, similar to the ampere hour figure, if you remember it, the table of the ampere hour, the C10, the C20, and C100. If you remember it, this curve, if we get back here, exactly, you can see this curve here, ampere hour, each discharge time has its own corresponding ampere hour, which is corresponding to a certain current. So each discharge time has its own discharge current. This can be obtained using this figure here. Okay, so this figure shows the performance of the battery that includes discharge current and hours. Okay, so if you delete all of this, let's say this is a 10 amperes. This, remember, this is a logarithmic scale. So here we have a 20 amperes. Okay, or let's look at here 10 hours. This one is at 20 hours. Okay, 20 hours. Okay, similar to the battery. If you go like this, it will be approximately close to 10 amperes. Close to 10 amperes. Okay. So in this lesson, we talked about the specs and datasheet of the battery. Hope this lesson was helpful for you in understanding more about reading the datasheet of the batteries. In the end, I would like to thank you for watching this lesson. If you would like more helpful electrical engineering courses, make sure to check out our Academy, Khadija Academy for electrical engineering courses. You will find helpful electrical engineering courses, paid courses, and also free courses. Thank you and see you in another lesson.